These are the video guided notes for lesson 5.3, writing proportions. Your I can statement, I can write and solve proportions using examples from real life. So a common one that we see often with proportions is recipes. You have a recipe and it's to feed so many people, but you're not always feeding that exact number of people, so you have to adjust the recipe based on how many people you are feeding and what the recipe calls for. If it's, feeding, the recipe would feed 4 people and you have 8 people coming over, then you need to double everything. So everything needs to be proportional to keep the taste the same. So it says that a chef increases the amount of ingredients in a recipe to make a proportional recipe. The new recipe has 6 cups of black beans. Write a proportion that gives the number X of tomatoes in the new recipe. So again, from previous lessons, a proportion is 2 ratios that are equal to each other. So we are going, step 2, we're going to write a proportion and solve it for the number of tomatoes. So we have the original recipe called for 1.5 cups, and the new recipe has 6 cups of black beans. So we're increasing the number of black beans from 1.5 to 6 cups. The original recipe had 1 tomato in there, so we want to know, based on the new increase of number of cups of black beans, what should the increase in the number of tomatoes be? And we're going to do this by writing and solving a proportion. There's different ways that you can set it up. We'll take the cups of black beans, so you can do this a couple of different ways. We can go ahead and put the 1.5 cups over the 1 tomato. So we have our original recipe numbers together, and we can set that equal to the 6 cups over the new number of tomatoes that we need. We can call that X. So we have cups on top on both fractions, and we have number of tomatoes on the bottom of both fractions. So you can set this up several different ways. The key here would be, no matter how you set it up, that the 1 and the 6 are diagonal of each other, and the X and the 1.5 are diagonal of each other. So we could have also set it up with the black beans in 1 fraction. So I could have put 1.5 cups of black beans over 6 cups of black beans. And then for the tomatoes, since I have the original over the new recipe, with the beans, then I need the original over the new. So the original called for 1 tomato, and the new calls for an unknown amount of them. So again, you can see we still have the 1.5 and the X diagonal of each other, and the 1 and the 6 diagonal. The only thing that changed, the 1 and the 6 flip-flopped around. So either way, we write that. Again, as long as those numbers are diagonal, you will end up getting the correct answer. So we multiply them. If these 2 fractions are equal to each other, cross products are going to be the same. We learned that in an earlier lesson. So I will multiply 1.5 times x, which is going to give me 1.5x, and that has to equal 1 times the 6, the opposite cross product. And 1 times 6 obviously is 6. And now it's just algebra. We want to get that x all by itself. To get the x all by itself, I need to get rid of the 1.5. The 1.5 next to x means multiply. The opposite is to divide. So I divide both sides by 1.5. 1.5 divided by 1.5 equals 1, canceling out, leaving x all by itself. And then we have 6 divided by 1.5, which gives us 4. So our answer here is 4 tomatoes. So if the recipe increased the beans from 1.5 cups to 6 cups, then the tomatoes would need to increase from 1 tomato to 4 tomatoes. So our answer is 4 tomatoes. Now it says using the original recipe to write a proportion and solve that gives the amount Y of water in the new recipe. So if we go back to this original here, the first problem, here's our original recipe. There's 2 cups of water in the original recipe, and we want to know how many cups of water will be in the new one. So we can still use the number of cups of black beans here to write our proportion. So we know that there are 1.5 cups of beans in the original, and we know that there were 6 cups in the new recipe. So 1.5 cups of beans in the original. So again, we have the original over the new. So we got to keep the other fraction consistent with that. And for the cups of water, in the original recipe, there were 2 cups of water. So 2 is the original number of cups of water we needed. So it goes on top. And x, or whatever variable you choose. Actually, it says amount y of water, so we should use the variable they give us in this case. So y would go there. So 1.5 cups of beans over 6 cups of beans has to be equal to 2 cups of water over how many cups of water. So we use our cross-multiplying method here. Again, 1.5 times y is 1.5y. That has to equal 2 times 6, which is 12. And then again, we want to get the y all by itself, so we have to get rid of 1.5. It is multiplying the y, so we will divide both sides by 1.5, and we get y equals 8. So if the original recipe had 1.5 cups of beans, and we increased that to 6 cups of beans, and if there were 2 cups of water in the original recipe, then with the proportion we need, we would need 8 cups of water in the new recipe. Problem 3 here, you can buy 3 t-shirts for $24. Write a proportion that gives the cost C to buy 7 t-shirts. So the amount of t-shirts is proportional. We don't get discounts for buying in bulk here, so we're going to set up 2 fractions equal to each other and then solve for that. Generally, money goes on top, so I'm going to put the $24 on top and 3 t-shirts on the bottom. So it's $24 for 3 t-shirts. And I'm going to set that equal to C, the unknown cost, over 7 shirts. So you can see in both fractions I have the money on top and the shirts on the bottom. And again, you wouldn't have to have your proportion set up exactly like mine. As long as you have the 3 and the C diagonal from each other and the 24 and the 7 diagonal from each other, then you set up the correct proportion. If you don't, then you have set up the incorrect proportion and you're not going to get the right answer. So now we do our multiplying. 3 times C would be 3C, and 24 times 7 would be 168. And again, we want to get C all by itself. C is being multiplied by 3, so we divide both sides by 3. The 3's are canceled. C is now by itself. We do the math, 168 divided by 3, and we get 56. So it would cost $56 for 7 shirts if it costs $24 for 3 shirts. So now you got some problems to try on your own here. Number 1, write a proportion to find out how many points a student needs to score on a test given a test score. So again, you're setting up 2 fractions equal to each other. I'll give you a hint on this one. 40%. The word percent means out of 100. So as a fraction, 40% would be 40 over 100. A hint I'll give you to help you set that up. Use the table to write a proportion. So we got your 4 numbers there with the W in there. The school requires 2 computers for every 5 students. Write a proportion and solve. That gives the number of C computers for 145 students. So if 2 computers are given for every 5 students, how many computers are needed for 145 students? Set your proportion up, cross multiply and solve for C. School swim team has 80 swimmers. The ratio of 7th grade swimmers to all swimmers is 5 to 16, so that means you have 5 7th grade swimmers for every 16 swimmers. Write a proportion that gives the number of 7th grade out of the 80. And then this one, they're telling you there is a mistake. Describe and correct the error in writing the proportion. So again, just pay attention to your units. Make sure everything on both sides of that equal sign is consistent. And then the exit question was the first step when solving x over 15 equals 3 over 5. So what would the first step be if you were going to solve for x there? Finish those up for homework.